So, once again, today we're going to be going over just pumping lemma and Turing machines. So, um, just to start off with, what do you need to know for this exam? For pumping lemma, you're going to need to know when to use it. And when do we use it? Well, we're going to be ending up using it when we're proving if something is not regular or not context-free. This is basically a proof that tells us whether a string is not regular or not context-free. And we're essentially going to need to know when we want to use it, because that will actually help us a lot in choosing whether we have to prove this, whether it's not regular or not context-free, or in the easier way of doing it, if you can just straight up make yourself a regular expression or grammar. So we'll go over a couple of those questions just to kind of show the differences between whether or not you're going to be using it or not. So you want to know when to use it and how to use it. For how to use it...
I hear your iPad sound, but I can't see your screen. I don't think you're sharing.
Oh, shoot. Hold on a sec. Good?
Yeah, all good.
Okay, awesome. Sorry, I think when I started recording it, kind of just glitched out a bit. All right, so again, when to use pumping lemma and how to use it. How to use it is using the template. On this exam, you guys are gonna have the fill-in-the-blank version, hopefully. But usually every exam 2 that I've seen, she gives you the fill-in-the-blank version. Exam 3, you will not be as lucky, but there will be less pumping lemma questions. So usually if the exam has like I don't know, like 9 questions on it, I would think maybe like 6 of the questions. Hey, can you please mute yourself?
Can you mute yourself, bro?
I muted him. Okay. If the exam has about 9 questions, 6 of the questions would probably be pumping lemma. 3 use it, 3 don't use it. And when I say use and don't use, 3, you prove that they're not regular or not context-free, and 3, you would actually make the expression, grammar, automaton. So that's really what to expect with this. Next, Turing machine. What do I need to know for Turing machines? You want to know how to make an accepting string, diverging string, and rejecting string. Okay, now we're going to actually see that there are going to be a couple of different types of Turing machines. There's going to be ones that will end up like accepting or rejecting and not diverging, and there will be some that do diverge. So we're going to learn how to identify each of these. And on these questions, Turing machine questions, you'll either get a question where they ask you to make a regular expression or write out strings. When they say write out strings, this is honestly the easier option because you literally just write out the strings. You're going to just literally say if there's a string like A, B, C, you just write out like however many strings she asks for. Or you just write out the regex. We're going to do both. Sometimes I find that even if they ask for the strings, it's easier if you just make the regex anyway. Okay.
Hey, I'm so sorry to bother you, but do you think there might be questions about variance and like universal Turing machines?
I've never done universal Turing machines in her class. If you're in Reba's class, it might be different though.
Okay, because I have Reba and he did go over it, but it didn't show up on the review sheet. But I wasn't sure if it might show up on the exam. So yeah.
Yeah, see, this is actually Reba's first time teaching it in a while, so I really don't know what to expect for his class. I know that his tests and content do differ from Obernick slightly. For instance, like he'll actually ask you to convert between deterministic and non-deterministic not Turing machine, sorry, automatons, while Obernick just tells you write one or the other, it doesn't matter. But as far as universal Turing machines, we never really went over them in class. Maybe she mentioned them once, but they've never been on the exam. I've never really seen any questions on them, so we're not going to be going over those.
Thanks.
Yeah, the only questions that she has really, which if you guys take a look at the problem book, or I mean, I know some people have posted some questions, but usually they'll ask for an accepting, a diverging, and rejecting state string. Um, and you can like see in the general chat, like someone posted like what a question would look like for that. That's really what it kind of looks like.
Oh,
Okay.
great. Thanks.
Yeah, sorry about that. Again, we're just kind of sticking with the Orbernix stuff here, but there will definitely be some stuff that overlaps. I would ask Reba though about that. Okay, so with Turing machines, right? We're just sticking to regular Turing machines. Um, so you'll be asked accept, diverge, reject. You'll be asked either to write a regex or write out the strings for that. Okay, and the last part of these questions, everybody's favorite question, algorithms. These we're going to ask you to use either Rice's theorem or Kleen's theorem to prove if it's a theorem. Not if it's a theorem, geez, if it's an algorithm. I think there was a video I posted last semester that went over this briefly. I will be completely honest, Oberlin kind of does rush through this with like a lot of heavy duty theory. And I'm not entirely sure about this. This was also the one topic that Clint did not go over very much either. I might try to see about having a separate review session for this, to be honest, if I'm able to figure it out. I also know that Kevin does this better as well, so I might see about doing that. But for today's thing, we're going to try to focus mostly on pumping lemma, both cases, and Turing machines, accept, diverge, reject. So this is the main stuff that you'd want to focus on. So pumping lemma will likely have the brunt of the questions. Turing machines would likely be, if there's 9 questions on the exam, expect maybe 3 questions of Turing machines. Each of these is going to have likely parts A, B, C are going to be to make accept, diverge, reject. And then if there's like a D or an E, those parts are going to be more for algorithms. So when people ask, hey, what are the algorithms? Go to a Turing machine question. You're going to see them. The questions are always really kind of structured the same in the sense that it's always going to be make an accept, diverge, or reject regular expression or string. And then the end is going to be based on the algorithm kind of questions. This is the structure of your exam. Before we go into the content, does anyone have questions? Okay, and one last thing. Turing machines are worth more points. Pumping lemma, less points, but more questions. Meaning that even if, let's say, Turing machines are hard, but you can do pumping lemma easily, you can still get points because there's a lot of questions on that. And if you're like me who hates pumping lemma, then Turing Machine is indeed worth a lot of points. So you can maximize your points. Point of the story, maximize your points with what you're better at. Now, I'm gonna take, if someone could just take a screenshot of this and just post it in the chat so people can see, because this is probably gonna be like biggest question, like what's on the exam and stuff. Does she give partial credit on Turing machines? That's a good question. Sometimes if she's nice, sometimes she won't. I recommend having something is better than nothing. There's a chance she might write that your answer is garbage. There's a chance you might get points. Do the questions that are easier to you first. Don't like attempt a question that you're really not sure about when there's another question that you can easily get points for. Also, actually, about that, let's say you're very good at accepting strings, but you're terrible at rejecting strings. Do the accepting string question. Don't worry about the rejecting. If you can do part A and B, but you can't do C and D, do A and B. Leave C and D blank. You don't care about those. Half points, better than no points. And she grades each part separate, so that she definitely gives partial credit for, but partial credit per individual point, like maybe if you get half the regular expression right, she may give points, but there's no guarantee on that. So I hope that clears it up. All right, with that being said, let's get into the actual stuff. Oh, thanks guys for posting that. All right, I'm gonna start out with, all right, first things first, how do you feel about Turing machines? Is it okay if I go to a left one first, or do you want to only go to the right? If you have no idea what I'm talking about, also let me know about that. Because Turing machines can move either to the right or to the left. Left means that it kind of goes backwards and rewrites the tape. Both? Okay. Just like in general, like if you guys have experience on Turing machines first, I could just kind of skip to the left ones because those are a little bit more confusing. Or if you want, I can do a quick right one to get everyone warmed up. Can we do both? Yeah, sure. Let's see. I'm gonna take spring 2022 exam number 2. Okay, this is a nice easy one. Yeah, sure, this is good. Yes, this is recorded. Alrighty. Turing machine. First things first, we have a couple of different symbols that we have to keep in mind here, right? We have Q, capital Q. This is our states. Capital Q is representing state Q, state P, state T. What are our states? These are the first column in our Turing machine. So this is your state, current state. This character here is our sigma. This is what we're reading. This is the state we're going to. I'm not very good with the Greek letters. I honestly forgot what that symbol is, but I just know that that is the state we're going to. This A is referring to the character we're writing. This is what goes on your tape. If you hear Obernick talking about a tape, this is what gets written on that. But we'll go through that in a moment. And lastly, this is the direction you're going.
Sorry, can you zoom it a little bit?
I think that's gamma. Yeah, I think you're right. Okay. So this is our basic Turing machine, and what each of these symbols represents. So with that being said, M has a one-way infinite tape. So if you notice, all of these directions here at the end are all R's, meaning we're always going to the right. Some are going to be a little harder. We're going to go to the left at some point, but we'll get to that. And B is the designated blank symbol. Okay, let L0 be the string on which M halts. Let L infinity be the set of strings which M does not halt. Okay. Now, there are two types of Turing machines to keep in mind. Ones that accept, ones that don't accept. To accept or not to accept. It's a matter of, do they tell us what the final state is? This does not tell us what the final state is. It will literally say something like F is equal to, I don't know, let's say Z is the final state. Does not give us this, does not accept. Meaning that this is essentially going to kind of loop. It will not accept. You're going to kind of either diverge or reject. So, I mean, not diverge. In this case, we're going to halt. So, quick thing about this. If an accepting state is given, you can either accept, reject, diverge. If it's not accepting, you can either halt or not halt. And in this case, this is going to be kind of like rejecting. So just some context, since that's also an often popular question as well. All right, with that being said, we want to see the ones in which M halts and which M does not halt. All right, when we think about halting, right, this is essentially where we're going to be diverging. Okay, hi, if you could just mute yourself, thank you very much. I love being a mod and being able to just mute anyone. All right. So with that being said, where are we halting? Well, this is essentially where we stop printing characters out. Where do we stop printing characters out when we get kind of stuck in a loop? Let's draw a quick little automaton out to show what this Turing machine is doing. First things first, we're starting out in state Q. State Q is this column right here. I have 4 choices here. If I read an A, I write an A and I go to state T. If I write a B, I go to state P. If I write a C, I also go to state T. And then if I do, I could also halt here in the sense that I draw a blank. And what this is going to essentially do is give me an infinite loop of blanks. So right here is a halting example. To draw this on a tape, I can say something along these lines. I can do, well, these would bring me to a different state. If I were to have a blank, this is where the end of the tape is, and I have blanks for the rest of it. So that's what we're saying by halting. So now, that's one case. What if we went on to the next state? Let's take a look at A and C. That led us all the way here to state T, right? T says I can loop an A, a B, a C on to state T. Notice here I went from state Q to state T. Here I'm going from state T to state T. All that is a loop. I can do an A, a B, or a C, and loop as many times as I want. This is not like an automaton that's actually going to be able to stop at this point, except a string. So I'm not going to have like a little circle there. It's kind of like an infinite loop in that case. Now, I'm stuck here. I can't go back. There's no going back, nothing else I can do. So with that being said, I have no other choice but to take a look at P now. If I started out with a B here, I went to state P. What is P telling me? Well, I can do a loop A, a loop B, a loop C, all on P. Wonderful. Looks awfully familiar, but we have an escape route. We have, once again, another blank, meaning I can stop here and draw infinite blanks. This is an example of halting. I'm halting the loop. So notice that in T, I cannot halt. It's a constant infinite loop. P, I can loop, which is good. So I know because of this, I have two cases in which I can halt. A case here and a case here. If I were to draw a regular expression for this, which I know this is technically asking for strings, okay, but you can halt at Q and P because of B. Yes, exactly. So we're going to make regular expressions to show this. Yes, so you're halting at any state that you have this capital B at. And what is this going to tell us? Well, if I were to make a regular expression for this, in state Q, I must go straight to this state. I can't write any characters, or else that's going to take me to one of these states. I have to automatically take this path. So that means no characters. That's an empty string. Lambda. That's one option. Other option is if I go to state P and take my blank. What's that? Well, what takes me from state Q to state P? Only B. I must have a B. At this point, I can either take the blank and halt, or I can do a loop. This is an optional loop, A union B union C star, and then whenever I'm ready, I can then take my blank. Two cases for two blanks. Okay, but P can only ever halt if the current character is B, right? Yes, it will only halt at that point, because what's your alternative? Infinite loop. So can we ever actually execute that Turing machine? Yes, it can be executed. In the case that if I had a B, I go from state Q to state P. I'm doing this loop. Let's say I want to do an A, a B, a C, and then I stop. End of my tape, valid string. On the actual tape, you're just going to have a bunch of blanks at the end. isn't state T from Q by an A? Yes, that is correct. State T, this is a T, I get from either having an A or a C. Because notice it says from Q, read an A, go to T. From Q, read a C, go to T. Oh, yeah. I didn't want to have, let me just rewrite that. I did a script T, so it wouldn't look like a plus sign. Yeah. So this is a regular expression. If we hit B in state Q, P doesn't it go on forever, which means it will not halt. Not exactly. If we go straight to B, this just means it's just an endless string of B's. The trick is, do you get stuck in an infinite loop? How do I get stuck in an infinite loop? Well, if I had a string, A or C, and then I had, over here, there's no end. A, B, C, C, B, A, blah, 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 blah. I'm stuck in that string forever. It will not accept. No accepting, oh, I said it right here. There's no accepting state. Remember this? Do we have an accepting state or do we not have an accepting state? We don't have an accepting state. So in this case, we halt at B when we would diverge in a case of an accepting state. When we don't halt, that's where we get into our infinite loops. The weird curved upside down Y symbol is supposed to be the other possibilities of the regular expression. The weird upside down. Are we talking about this one? The one that looks like this? Or, oh, this one. Yeah, that's lambda. Yes, yeah. Lambda is just an empty string. Remember this from regular expressions, I think? Okay, yeah. Yeah, I know Obernick writes it different. I think Reba probably writes it different. This is a lambda. It's an empty string. Yeah, I know Obernick sometimes writes it like an H. I try to make it not look like an H. Yeah. Okay, yeah, I thought you meant this one for a second. That is the state that you, or, sorry, that is the character that you're writing. So, what is the question exactly asking us? The set of strings in which M halts and does not halt. When they say the set of strings, this is saying the regular expression, because the regular expression makes all strings. This is the halting, and then what is the not halting? Well, this is just the opposite, in the sense that, oh no. Okay, I don't know what just happened. Whatever. So, what is the example of not halting? Well, this is just following the other option. How do I get stuck in an infinite loop? Well, if I start out with an A or a C, I get stuck in state T. And then I'm stuck in an infinite loop. So basically anything that starts with an A or a C will not halt. Anything that's either an empty string or starts with a B will halt. Now, there's another way that they're going to ask a question based on this, and that's create strings. It might say like, oh, create 7 strings that are based on this. Literally, that's even easier because if you don't really have to construct the entire regular expression, you can kind of just go through the Turing machine and just kind of be like, okay, this is something that works, this is something that not works. But basically, if you were to find regular expressions, if you were to find valid strings that work for this, oh, hi, question?
Yeah. So basically, whenever we have a blank, that's mean it's hard. If we don't have any blank, then that's mean not hard.
I'm sorry, repeat that?
Like whenever we have blank, so that means it's hard. If there is no blank, so that means like there is no hard.
Exactly, yes. So
Thank you.
anytime you get to a blank, that's a halting state. Anytime there is not a blank, it's like an infinite loop, that's not halting. Okay, so do you think it's better to first write the state diagram of the Turing machine or just read the instructions and write? That is up to you. Starting out, I recommend draw out an automaton just so you can see it visually. Then, especially when you're dealing with harder automatons that go to the left, you should write out the tape. We're going to do that for the next one, but I just want to show you how this looks in an automaton. And then what you want to also do is when you're actually doing the exam, after a while, you can kind of just skip that step and just kind of look at it real quick, because you don't want to waste too much time on the exam. So do whatever you feel best about. There's no like one way of like doing it. Here, I will send that in the chat for you guys. All right, so one where we end with a B is halting. Ones where we go in an infinite loop is diverging, and then rejecting is when the string isn't accepted at all. That is if a final state is given. That's what I mean by accepting / final. We'll go over some that do have that. If a final state is given, reaching that final state is considered accepting. Reaching a blank state is considered diverging. And reaching no state at all, or getting stuck in an infinite loop, that's rejecting. When a final state's not given, like here, you have two choices. Halt if you get a blank. Don't halt if you get stuck in an infinite loop. So that's the difference between the two cases of Turing machines. Now, if you were to, I just see people are asking questions. This problem is not accepting. If the question gave you a final state, like f is equal to z, that tells you that, let's say they gave you a state z, and it did whatever it was. Getting to this state is your accepting state. Just like here, our goal for finding a halt was to get to a B, your goal for getting to an accept, in this case, is a Z. It will tell you this in the question, and we're going to do both. So not accepting questions are generally easier than accepting questions. Kind of depends. I'll tell you this. It's easier to do accepting and diverging than rejection, because accepting and diverging have more specific strings. Rejecting is kind of like everything left over, or in this case, not halting. So don't worry, they're gonna get harder, but they're still doable. Wait, for the halting regex, does the lambda mean B? Yeah, so when we do a B, it's not a character. It's just going down a blank. And anytime you have a blank or nothing at all, it's just a lambda. Notice that when I have this part and this part, I can think of kind of a lambda at the end here, but I don't need a character there. There is no character at the end. It's just when I'm done printing characters, that's it. You could think of it as end of your tape and you have blanks. I'm going to show you how to do this with a tape as well, if you hear her talking about tapes a lot. It's pretty much just another way of thinking of it. Sometimes the automaton's a little bit easier. For instance, you see, wow, I have path, path, blank path. Sometimes it's easier to look it like that. Find the way that works for you. Just on the actual exam, don't waste too much time drawing out an automaton or regex or whatever. Try to answer the question as fast as possible. Last thing about this question before we move on. This is asking for the set of strings, therefore it's a regex. It might ask for specific strings. If that's the case, straight up just make some strings up based on your regex. For instance, what are some strings that work for this halt? B on its own, BA, BAB, anything that starts with a B. Also lambda. You could put lambda there. There's no real, final definite answer. You could do anything. And the non-halting, basically anything that starts with the A or a C. AA, C on its own, CB, you get the picture. So those are how to do both cases. Do you write out a regex? Do you write out some possible strings? Good on this one? Because I'm going to pull up the other question in the meantime. Cool. If anyone wants to take a picture. Okay, I'm going to move on to the next question, which was a request. And this one is going to have a left state. So we're going to make it go a little bit more confusing. Doesn't that sound like fun? Yay! I know, right? This is so much fun. Don't worry, you guys. Just 2 more weeks. It actually is 2 more weeks and then finals. All right. So, we have a couple of differences in this question. First things first, there's an F, and it's not the type of F that Obernick likes to give. This is a final state. This is what I was talking about. This time it's given us a final state. We know that because of that, immediately there are 3 types of strings: accepting, diverging, and reject. Accepting means that I reach state T. This is a T, by the way. Right? Final state. You reach your final state. Diverging means we reach a blank, but this is where it's going to be different. It must be a blank going to the right, and I'm going to explain why in a moment. But just think, you want to reach your end of your string and have a bunch of blanks to the right. That's the goal for diverge, just like the problem we did before. And reject is kind of your leftovers. Think of an infinite loop. Can't reach T, which is your accepting, or B, which is the blank. So we're going to be doing these 3 for our strings. Now, we also have some more symbols here. Stuff to keep in mind. We have more states. We have a Q state, an X state, a Y state, and a W state, and a T state. Where is our T state? Over here. This is the goal to accept. Think of it as the finish line. What else is there? Well, sigma's kind of the same. We're only ever going to be really writing characters, because this is reading, right? Reading characters that are A, B, C. And what is our tape? There's going to be a capital letters in here. So tape is what we are going to end up seeing. And we have A, B, C, but we also have capital letters. Capital A, capital E, capital K. These are going to be written. And you're going to see in a moment. The last example, we read an A, we write an A. Like you see here, there's an A in the read position and an A in the write position. Keep in mind here, you read a lowercase a, you write a capital A. Another difference. Last difference. There's some lefts here, meaning the last example we wrote to the right. We had an A, a B, blah, blah, blah. In this case, we're going to be writing some stuff, having an option like an A or a B, and then going backwards and overwriting this to be more specific. It's going to make a little bit more sense in a bit. So those are the main three differences in a case like this, right? We have three possibilities for strings: accept, diverge, reject. We have capital letters that can be written, and there's left over here. So it's a bit more than the last one, but we can still do it. First things first, where are we starting? We're starting in state Q, right here. Let's do the accepting string first, because that is a little simpler in the sense that we have just one goal in mind. We want to get to T. Then we'll do diverge, and then we'll do reject. So first things first, I'm going to just draw a quick little diagram. This will not be, very detailed at all or anything, but just to understand where we're going. From state Q, I want to go to state X. Seems like I can write an A, a B, or a C to get there, right? If I write an A, go to X, B, X, C, X. Okay. So I'll draw out my tape. I can do an A, or a B, or a C. Keep in mind, I'm writing something different. Capital A for lowercase a, capital E for lowercase b, capital K for lowercase c. This is going to come back because when we go to the left, we're going to see
Would you question?
Yeah,
I have a question.
Mm-hmm.
Would you start off with the dummy node, like if it's possible to like just start with just the dummy node, if you like for like as a place starter, right? Like a dummy node, like string node n equals new string node in parentheses with null. But does that work as well?
That works. I think that's how Lord does it, right?
Yeah.
You use a dummy node, so it would be a string node.
I don't think we. That sounds more like code based.
Right.
We really don't do code based in this
Oh, you
class.
gotta be shitting me. First is equal to null. Is this what he would do?
Are you guys talking about a different class?
I think they're having their own conversation.
Okay, I'm just gonna mute. That
Yeah.
sounds way more like a 211, 212 kind of thing. I just got like PTSD for a sec. Yeah, if you want to write your questions in the chat, if you want to talk about that, but I'm gonna just keep going. Yeah, for a second there, I'm like string nodes, that's like 211, 212 stuff. This is not anything code based. I mean, there are code applications to this, but we're not gonna even mention that because like all you need to know is how to do the questions to do the exam. Like that's it. Anyway, so back to this, right? From state Q to state X, I either write an A, a B, or a C. And the key here is when we go backwards, right? We're going to see a string that has a capital A, a capital E, or a capital K. This was what was written. We read an A, we wrote a capital A. We read a B, we wrote a capital E, etc. Just want to clarify that. This is what's going to come back when we take a look at the string to the left. Next, now we're in state X. I'm going to ignore the diverging here for a sec. There is a diverging state, yes, but we're going to ignore that because we have a single track mind. We just want to get to the end accepting state. Now I'm in state X. I can now do a loop. A on X, B on X, C on X. That is just literally A union B union C star. Meaning I can skip it, I can do it, makes no difference to me. When I'm ready to escape that, I hit this state over here. Now you probably are saying, but isn't that a blank? Aren't you not doing diverging? It's not the blank that causes a diverge. Remember when I said we care about blanks to the right for diverge? This is a blank to the left. What a blank to the left is saying, end your string, put a blank. It's like putting a period at the end of the sentence. Now you're looking to the left. This is the end of your string. It's not a sea of blanks, like in the case of a diverging case. This is quite literally just a single B. It's a period at the end of your sentence. Now, we're going to go backwards to the left on our tape. And the best way to put this so that you don't get confused, think about old VHS tapes, which maybe if you're a little older, maybe you know it. I myself am Gen Z, so I just know them a little bit, but with a VHS tape, you can record, but then you have to kind of rewind the tape backwards. Otherwise, you're kind of stuck at the end of the string, right? If you end stuck at the video. If you want to watch something at the end or you want to re-record something, you got to rewind and get to that point. That's kind of what we're doing here, since we're literally thinking of this as a tape. We're rewinding the tape and gonna write something somewhere in the middle. So, with that being said, we were in state X, and now we're going to state Y from the left, right? Remember, X is where we came from, Y is where we're going. We read a B, we write a B. All that's saying, I put a B here. This is the blank, this is the period at the end. We are now in state Y. Okay, now, quick little detour. What do I want to get to? I want to get to T over here. So how am I going to get to T? Well, I have to reach this state here to get me to W. W brings me to T. So I have a couple of cases here. If I see a lowercase b, then I can go to state W. Well, the only way I can get a lowercase b is if I'm looking at the left of the string, and if one of these characters from this A union B union C was a B, then that would bring me to this state. Now, if this was a 0, this means the first character that I'm looking at from the left wouldn't have been a B. It would have been one of these capital letters from state Q. Question: the B specifically needs to be already present from when we were in state X. Yes, in order to get to state W. So what that is saying is that in order to get from state Y to state W, I need a B there. But in case this star was actually a 0 and this never happened, this means I would end up having a capital letter. Yeah, so X is being overridden. So if I get stuck in looking at a capital A, capital E, capital K, this means that I see an A, let's say, I write it over with another A, and I go back to state Q. Now I'm kind of at the start again. And I can write an A, a B, or a C, which then brings me back to state X, which brings me back to this loop, which brings me back to state Y. What this is saying is that essentially I cannot escape from writing a B in this case. I have to have a B in order it is being recorded, but if you're welcome to record it yourself too. This Q would essentially just loop us back to state Q, loop us to state X, loop us to state Y. Oh, look, we're back to where we started. Meaning you're essentially forced to take this A union B union C star, and I need to read B as my first character. So, with that being said, all right, cool. I'm in state Y, and I read myself a B. This B tells me that having a B at the end of the string, because remember, I had a period here, the B, and I went to the left, the first character I saw was a lowercase b. This passes the test and brings me from state Y to state W. Okay. So what I know from this is I've overridden this A union B union C star to make it a little bit more specific, in that within that star, I must have a B. So I'm going to end up with a string. I'm still working on it, but so far my string is looking kind of like this. I need an A union B union C in the front to get me from Q to X. I could have anything I want from state X here, but from this, I must have a mandatory B at the end. And this B is going to help me go from state Y to state W. And this is kind of what my string is looking like right now. But we're still not at the end yet. We're now in state W. So now in state W, I have three states. An A, a B, a C involves me to loop on state W and go to the left. Oh, is the right side of the screen? Actually, is that better? Okay, awesome. Yeah, so what this is saying is that an A, a B, a C, reading an A or B or C, loops back on state W from the left. What that's saying is I am backtracking on this A union B union C star that I created. I had a B. I could have any other A union B union C star. Backtrack on any character I want. And it's just going to keep looping through state W. But my goal here is to backtrack to a point till I get a K that I've read. Now you're probably saying, what's the K for? Since when do I write capital letters? Since state Q, you write capital letters. We backtracked all the way to the beginning at some point. And the only way I could read a K is if I wrote, you got it, a C. Meaning I now overwrite this A or B or C to be more specific and to only be a C. My string now is a C, A union B union C star, B. That is my accepting string. And let's go through this from the left to the right, so reading it normal, as to why this is the case. So a C prints me out a capital K. I go to the right. I'm in state X. State X, I do an A, B, C loop. Okay, I do whatever I want here. Now I go backwards from state Y to state Y. Okay, I have to read a B at the end of my string, because remember, this is the end. I read a B. Great. Now I'm in state W. State W backtracks along an A, a B, a C, any number of characters I have here, until I get to this point where there's a K. Oh look, I made it back to the beginning of the video where there was a K written because I had a C. Therefore, this is an accepting string. To make a set of accepting strings, I use the regular expression C, A union B union C star, B. That's it. Questions? Did that actually make sense? Because this can be kind of tricky. Oh, awesome. Really great to hear that. I think Turing machines get a bad rap as the hardest topic on the test. If you can do a left-facing Turing machine, you're in really good shape. This is like the hardest type of question. Now, we still do have 2 more cases, but my recommendation is accepting and diverging are usually the easiest cases. I say focus on this. Rejecting might get a little tricky. If you can't do rejection, that's okay. If you can't handle rejection. Yeah, if you can't handle rejection, that's honestly fine. You're totally good. You can get partial credit as someone asked. This is 18 points. That's a big chunk of points. If there's like, I don't know, if there's 3 parts to it, let's say accepting, diverging, rejecting, and you can do 2 of them, 12 points is still a real good chunk. Is this question asking for a regular expression? Great question. This is... I actually don't know. Write a regular expression. Yeah, okay, this is asking for a regular expression. So if you were to not ask for a regular expression, literally, it's even easier. Just straight up take this and make a bunch of strings out of it. At the very minimum, it must start with a C, end with a B. This is your shortest string that you're able to use. It's your base case. Have a string that has a C, something in the middle if you want, and then a B. That's literally it if they ask for specific strings. Okay, next question. So as we started going through the accepting string, the C becomes the K that we need later on to reach the final state. Yes, exactly. You got it. Think of it as like you need that secret weapon at the end of the video game or the movie to beat the final boss. Reach the accepting state, reach the final destination. Video game references for the win. Woo!
The strategy here is really to just walk through the states and see where the final regular expression is.
Yep, exactly. You're literally walking through the string. Is it a viable approach to work backwards? Yeah, absolutely. When you get good at these, like, honestly, even if you're not good at them, like, just take a look and you say, capital letters, that seems suspicious. I wonder if that's going to be used at the end. Oh, look at this. I need a K to get to state T. Okay, you know, if that's the case, I think, just a hunch, there might be a C in the beginning. So, yeah. When you're starting out, you're better to write it all out, but as you do more of these, you're going to notice patterns. So, yeah, do whatever works for you. Question, and as we're going back to the left, we overwrite prior states like X to Y, Y to W, all the while checking the symbol under the current state. Couldn't have said it better myself. You're going forward, very vague, right? We started out with the string A union B union C, A union B union C star, and then we made it more specific in the sense I needed a C here and a B here. You could think of it as making a rough sketch and then refining it as you go backwards. Let's work on diverge now. Diverging ain't bad either. Okay, diverging is often shown with an infinity sign. So in case you ever see like L infinity sign, that just means it's diverging. Think of it as an infinite loop of blanks. All right, so what do we want in a diverging state? Blanks to the right, not to the left. The left is just a period at the end of a sentence. To the right is what we want. So let's first take a look at where are our blanks. There's one here, and that's it. So first things first, the obvious one. You start out with the blank. Imagine you just skip all the symbols and you just have a lambda. There you go. That's one answer. Now let's make sure that there's no other answers. A lot of times, I'm gonna let you in on a little secret. The answer might be as simple as just lambda. If there's only one blank stage and it's at the beginning, if there are no loopbacks, it will just be lambda. This does have a loopback, so we kind of just need to be careful of that. Let's check it over and make sure that's the case. So we know lambda's one case. Well, if I were to do this from state Q to state X, A, B, or C, this gets me from Q to X. In state X, I can do A, union B, union C, star, whatever I want. I then draw my blank. I'm in the left now, in state Y. I do not want to go to W at any cost, because then that locks me in that and I will not be able to get back to a diverging state. But if I see an A, an E, a K, I can get back to Q. That's the goal. I want to get back home. Meaning that, well, the only ones that could have written that was this initial A, B, C, right? A, E, K. That means I can't take this. Because if the first character that I look at is going to be a lowercase letter, then that's going to just loop me over. I want to see an A, an E, or a K. So, with that being said, this means that my first character needs to be an A, B, or C. All right, so if I'm in state Q now, and I have a string that's just an A, a B, or a C, I can also get back to this state here. So because of that, a single character, like an A, a B, or a C, would mean I would go from state Q to state X, would skip all of this, end my string, and then when I loop back, I'd only have the single character that came from here, Q, meaning that single character printed a capital letter. That capital letter is like a teleporter that teleports me back home and brings me back to this state right here. Because of that, my final regex will be this: lambda or A or B or C. Diverges are usually a little simpler because there's usually less cases to keep in mind. Rejection is going to be fun. Why is there no star? Great question. Where was the star? The star came from state X, right? The problem with that is X brings me to a loop, and that loop I look at when I go to the left, right? Because of that, if I look at any character that's not an A, an E, and a K, I cannot go back to state Q, and state Q is the only one that I can diverge in because it has a capital B. This means the first character I look at from the left must be a capital A, E, K. The first A, B, or C that came from Q. This is because it needs to be the first character that I look at from the left. I can't have anything coming from this star right here. That's why we don't have the star. X is also diverge. No. Okay. This is what I said before. When you have B to the left, it's a single B. It acts like a period at the end of your sentence. Diverging is only blanks to the right, because that is like an infinite number of blanks. The only time that we can diverge is right here, because it's blanks going to the right. I got the lambda portion, but completely lost on the A union B union C. That's understandable. And since we can't have any prior characters before A, E, K... Yeah. I missed the first part of this question. Is there a video that explains how to traverse the set? Yes, there is. If any of you guys are still confused on Turing machines, there is one that I go into depth with these in the Everything You Need to Succeed channel. I think it literally says Lauren Turing machine review or exam 2 review. Just take a look at that. I go through it super in depth. Yeah, so definitely take a look at that. And this is being recorded, so you guys can take a look at the end. I'm probably going to do it in 2 parts just because I do not know how much storage is going to be on my computer. We want to create multiple B's to the right. Is there a study session after this? Asking for a friend. If you guys want, I'm probably going to call it quits after finishing this and pumping lemma, just because I do want to get to my own stuff too. But if you guys want another study session on specific topics, let me know. Where's the recording going to be posted? In the Everything You Need to Succeed channel. Yep, you got it. Thanks for posting that. Alright, let's go through this one last time. Alright. Let me erase this stuff. I think it's getting a little confusing. Ooh, that's not good. Okay, yeah. Alright, so with this being said, let me just go through this over here then. Alright. We have to take 2 things into account. One is if we automatically diverge over here. That's no characters, just diverging. That's the lambda. The second case is when we loop back. Because remember, what does this kind of look like? Q goes to X, which loops on itself. And then we kind of look backwards as we go to state Y. And if we see an A, an E, or a K, this lets us go back to Q. This is kind of like what we're looking at. Isn't this A union B union C star? So the star lets us have infinite number of characters. This would let us have something like A. This first A would bring us from Q to X. The second A would be a loop on X. The third A would be a loop on X. Now I do my blank and I look backwards. Alright, my first character is an A. We have an issue. There's no case for an A here. Because of that, this is actually a sneak peek of rejection. But we can only have a case where we have A's, we can only have a case with a single character. So looping back to Q will make sure we can reuse blanking Q. Yes. There's 2 cases. One is if we just go to Q straight, lambda. The second is if we loop back to Q. From Q we go to X, from X we loop back on Y. If you see an A, an E, or a K, that lets you loop back to Q. Yeah, you're all good. Lambda's kind of related to stars because remember, star is 0 or more. So just remember the more part too. Because 0 could just be lambda, but if you want to kind of break it up, that's when you put lambda on its own. Lambda has a bigger role in Turing machines than it did in regex. Okay. So with that being said, we know that that single character brings us from Q to X, right? And it writes a capital letter. Ignoring all of these guys, when we want to go to state Y, we look at the first character to the left. We can't write any junk there. We need that first character to the left to be a capital letter, because that is what's going to loop us back to Q, getting us to our diverging state. A little better? Yay!
I have a question.
Sure, what's your question?
So like basically we put the blank because in the last line of the first transition we have Q, BQ and BR. So that way we put the lambda, right? And then union because when we go to the X, we have loop on X, and then on the X we're gonna go to the Y, and when we go to the Y, then we have like the capital letters, and we already have in Q, so we go back to the Q because we are going to the left, right?
Yes.
So we get okay.
Yeah.
And then we're gonna put like A because on A, capital A, E, and K we have the A and B and C. That's why we put A union B union C.
Yeah, exactly. That A union B union C is a single character that prints out one of these capital letters. And when we go to the left, we see that's the first character that we're looking at. And that lets us loop back to Q. Okay. So, with that being said, let's do a little rejection. I think I've foreshadowed the rejection a little bit. I find that it's best to handle it at the end because now you get a better sense of, okay, what causes an accepting state? What causes a rejecting state? Diverging state. Rejection is kind of everything left over. Rejection means you get stuck in a place and there's no way out. So, with that being said, I want to take a look at our accepting string because that's going to give us a real big hint as to what our rejecting string is going to be. What's our reject? You have a question?
Huh?
Okay, no, okay. So last thing is going to be rejecting. All right. So we know that to get an accepting string, it has to be any string that starts with a C, ends with a B, right? Well, when we do a rejecting string, we're going to flip that upside down. This one's actually quite easy because it's only two cases. Strings that don't start with a C and strings that don't end with a B. So if we are going to have a string that doesn't start with a C, right? Any string that starts with an A or a B, this will make sure that we don't have a K, thus meaning we'll never accept. It doesn't even matter what comes after, right? Some of you might be saying, oh, what about the B? I don't want to include the B here because the B is kind of already in here. This string can generate something like A, B, right? This first A would bring me from Q to X. This second A would be somewhere in X. This B would allow me to traverse back to W when I look at it from the left. But when I go backwards a few times, I don't have the C that gives me a K, so I reject on this. So this is definitely an issue. Now, I got to take into account the other case, right? This is one case. That's if I start with a C, but I never end up having a B over here. Now, I'm going to be honest here. I actually don't even need the C here, because this A or B or C, once again, can put a C in the beginning, and then some other characters, blah, blah, blah. But if there's an A or a C here at the end, I get stuck right here. There's only a case to look for if there's a B or a capital letter there. But since I have an A or a C here, that's not going to happen. The only case is exactly, but would it hurt if it started with a C? Yeah, that could potentially pose a problem. So if I had a case that was like, hold on, am I missing something here? Yeah, if this started with a C. Well, okay, if this started with a C, it really wouldn't matter because when I got up to this point here, there's an A or a C here. I have no way of getting to state W unless there is a B in the last position. So there could be a C here. That's totally fine, but remember, when I'm doing a regex, I want to encompass all possible states. That's why I'm not limiting myself to just the opposite of this expression. Well, it is the opposite of this expression, but I'm not just saying, oh, C, A, B, C, and then A or C. No, I'm putting the C in here because I can start with an A, a B, a C. Doesn't matter to me. It just can't be it just can't be a B in this position to reject. So with that being said, these are the two cases. And with that being said, I believe that would cover it all. Now, the other thing to keep in mind is to handle lambda cases, but we already handled that in Diverge. So because of that, it's not like there's a lambda case here. Because if there was no case here to handle a lambda, you'd also count that as a rejection. Wait, can't this diverge? Okay, technically it could, but that's only if you took the blank path, in the sense that, actually, let's go through that. A or B, right? A or B, then goes to state X. Actually, that might actually diverge. Yeah, you know what? You got a point. We might need to make another character here to ensure that it doesn't diverge. All that would mean is that we'd have an A, B, or C, before this A or B or C star, or after. This ensures that we have a second character so that we do not diverge. Can you repeat how we got reject? I kind of got lost. Yeah, let's do this one more time because this got a little... This is the problem with reject. There's a lot of cases to keep in mind, especially edge cases. You could think of like from regular expression problems when you had to consider base cases, edge cases, very similar here. So with that being said, okay, we wanted to take a look at how to reverse the accepting string and taking into account the the diverging string. Rejecting is essentially, you can actually think of it as L accepts unioned with L diverge and take the complement of that. So essentially putting together everything in accept, everything in diverge, and taking the complement of it, the opposite of it. It's everything left over. So how do we get a non-accepting string? Well, we can't start with a C, and we can't end with a B. I know I have two cases. This first one does not start with a C. This last one does not end with a B. One thing taken care of. Then we need to take care of the fact that it can be any length except 1. This is because 1 is the diverging. This causes it to diverge, because we went through that, right? The single character prints out a capital letter. When you go from Q to X, backwards to Y, you look at the character to the first character to the left, and that is a capital letter, and then that causes it to diverge. So with that being said, you want to make sure that there's at least another character in there. So I sandwiched a little A union B union C in the middle here. And what this does is it makes sure that there's at least 2 characters. So this would mean a string like A, B, C, or something like that. And then the other one as well. Like A, B, A. So this would be the 2 cases to keep in mind here. How are we feeling about this? Yeah, of course, not a problem. I hope this helped a bit. Yeah, honestly, you gotta practice these. You really just gotta go through a bunch of these, and you're gonna recognize a lot of patterns. Once you know how to traverse a Turing machine, you're gonna be fine. Question, is there going to be pushdown for exam 2? Okay, I'm just gonna say this once. No pushdown unless she mentions it. 90% of the time, she will not get up to pushdown before exam 2. If she does, it's fair game. It's just like pumping lemma. If she does not mention it, it will only be on the final. I have a video on pushdown, by the way. Literally just watch that and you're fine. It's honestly an easier version of Turing machines. If you know how to use stacks, right? Think of last in, first out, LIFO. Think of a stack of pancakes. Yeah, take the one from the top. Just think of that, and that's literally pushdowns in a nutshell. Which topics does this exam focus on? Check general chat. I did an outline, but just pumping lemma Turing machines. So we're doing Turing machines now. We're gonna do pumping lemma, and that's gonna be it for today. I might do algorithms separate. To be honest, that's always been kind of a shaky topic for me. Clint's even struggled with it, so those are tricky questions. I'd say focus on the ones that are a little easier. Okay, what do you guys want to work on now? Pumping lemma?
Yes, please.
3 votes for pumping lemma. Awesome. Alright, if it's the case, I'm gonna actually pause the video here, and I'm gonna actually start uploading this Turing machine one. So give me like 5 minutes. We're gonna just take a 5-minute break.